Welcome to Homework Lib.
Over here, we're going to verify an answer given by ChatGPT about the electron configuration of the common ions of chromium. So the first thing that we need to notice is this mistake over here on the electron configuration. This is going to be incorrect. Remember that chromium 0 is going to have the electron configuration of argon 3d5 4s1 or something. So for this reason, after losing 3 electrons, chromium 3 plus is going to have the configuration argon 3d3. So this electron configuration is going to be incorrect. Other parts of the statement that are going to be incorrect are that, for example, over here it states that chromium typically loses 3 electrons to achieve a stable electron configuration similar to that of argon, which is not going to be true. For chromium 3 plus, we're not going to get a configuration corresponding to argon. Over here, it does give the correct electron configuration in contrast to the initial statement over here. And indeed, it is going to lose the 4s2 electrons first. Next up, it states that this configuration provides greater stability due to exchange energy considerations and Hund's rule, where electrons prefer to occupy separate orbitals with the same spin. And in this case, this description is more akin to the reason why chromium 0 has this electron configuration, because in this case, what is going to happen on chromium 0 is that the 5 3d orbitals and the single 4s orbital are going to be filled as such because adding an electron from the 4s into the 3d is going to incur into a repulsion energy coming from the coupling of electrons. So that description is going to be better for the electron configuration of chromium 0. It is not going to be as valid for the description of chromium 3 plus. Actually, in chromium 3 plus, we're going to avoid completely that problem because we're going to only have 3d electrons. So over here, that makes no sense. And then an example of a compound with a chromium 3 plus ion, that is okay. Now for chromium 6 plus, let me redact this part. For chromium 6 plus, the electron configuration is going to be correct. We're going to achieve an argon electron configuration. In these oxidation states, we have lost all of its valence electrons from 4s and 3d orbitals. That is okay. And now the electron configuration is going to be similar to argon. Notice that it tends to write down the same thing for both of the ions, regardless of it being chromium 3 plus and chromium 6 plus. And this is going to talk a lot about the fact that large language models are going to look at similarities in language. Thus, it is hard for it to differentiate the explanation for chromium 3 plus and chromium 6 plus. It tells you that both of them are going to have an electron configuration similar to argon. Next up, chromium 6 plus is less common than chromium 3 plus because it requires extreme conditions or extreme oxidizing agents. And over here, for example, now it is going to be less common. I would put that into question because even though the preparation of chromium 6 plus does require oxidizing conditions, it is so abundant that we have a lot of compounds containing either the chromate or the dichromate ion. So I can see that it is going to be less common, but it is hard to say that it is going to be enough of relevant enough for making it into a statement about electron configurations. Actually, this sounds more like a fact rather than an explanation on the ions of chromium. And with that, it would be all. Thank you very much and have a good one.